All right, lesson on 3D shapes and faces, including faces, edges, and vertices. We've talked about this before, so it's just going to be a review. Remember, faces are the flat sides. Okay, it's like thinking about your face. I mean, your face isn't flat, but sort of, right? So those, the flat side of the 3D shapes we call faces. The edges are like the lines, and the vertices are like the points. Okay? So then we just have to count them on the different shapes. Before we get to that, though, I want to remind you that prisms are named by the shape of the two bases. Oops. Oh, yeah. Of the... Because, remember, prisms have two parallel bases with rectangles in between, and we name the prism based on the shape of those bases. For example, we have a pentagon there, a pentagon there, so we know that this is a pentagonal prism. If you just say pentagon prism, that works too. Pentagonal just makes it an adjective. Now let's count the faces, edges, and vertices. Okay, so I have, again, this front face and a back face. And then it's a little hard to count the side rectangles on a picture, but think about the fact that I have a rectangle for each side of my base. Because there's this back one, that's 1. There's this top one, 2. This other top one, 3. This one over here, 4. The bottom is 5. Plus my front and my back gives me 7 faces. I have some of them in 3D form if you would like to actually count them, like hold them and count them, just let me know. Edges, I can just count the lines. If you want to do it on Cami and have to actually trace over it, not a bad idea. I like to count them in some sort of pattern. So I like to count this base is 5, 6, 7, 8, 9, 10, the other one, and then I count the long lines in between. So I have 10, 11, 12, 13, 14, 15. On a prism, it's always going to be 3 times however many sides my base has. So it's a pentagon, which is 5 times 3 is 15 edges. I don't expect you to memorize that, but just so you know. There is a pattern to it. And then my vertices, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's always 2 times the number of sides of my base. 5 times 2 is 10. One more example, this time with a pyramid. And again, we name a pyramid similarly. It's named by the shape of the base. This time, instead of having 2 bases, we just have 1, and then it all comes up to a point. It's the difference between a pyramid and a prism. Faces. Well, first, what kind of pyramid do we have? 1, 2, 3, 4, 5, 6 sides on our base, so it's a hexagon. So it is called a hexagonal pyramid. All right, there's a lot of triangles on a hexagonal pyramid, so let's count those first. So I have 2 in the back, 1 right there, 2 right there, 1 kind of over on the side here, so that's 3, and then I have 3 in the front. It's a little messy, but I have 6 triangles, and then the bottom face makes 7 faces. Oh, just like the pentagonal prism. Didn't even mean to do that. Let's count our edges next. Edges is the place where 2 faces meet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in a pyramid, instead of being 3 times as many, it's only going to be 2 times as many sides as the base has. And then vertices, the points, the place where edges meet. We have 1, 2, 3, 4, 5, 6, and the one at the top, 7. So it's always going to be how many sides the base has plus 1 for that top vertex. Okay? Again, I would recommend drawing on the cami, which can be hard, but I think it'll help because then you won't accidentally double count anything. Because when you're going around, sometimes it's hard to forget or hard to remember what you've counted already. Or I have some in 3D form. If you would like to hold them in your hands and count them, just let me know. Let me know if you have any questions. I am here to help. Good luck.